Every structure you see around you, from towering skyscrapers to slender bridges, from aircraft wings to everyday tools, relies on a delicate balance between stress and strain. These two interconnected concepts form the foundation of structural strength and safety, and understanding them is essential for every engineer. Stress and strain tell us how materials respond when forces act on them, and they are the language through which physics speaks to engineering. Stress is defined as the force applied per unit area within a material. Strain, on the other hand, is the measure of deformation resulting from that stress. Together, they allow engineers to predict whether a structure will bend, stretch, compress, or ultimately fail under load. Hooke's law, one of the cornerstones of material mechanics, states that within a material's elastic limit, stress is proportional to strain. This relationship allows engineers to quantify the stiffness of materials using moduli such as Young's modulus, shear modulus, and bulk modulus. For engineers, stress and strain are not abstract ideas. They are the criteria for designing safe, efficient, and durable structures. In civil engineering, these concepts are applied to calculate how much load a bridge can carry, how tall a building can be built without compromising safety, and how materials should be chosen to withstand varying environmental conditions. In mechanical engineering, they determine the durability of machine parts, shafts, and gears. In aerospace engineering, stress analysis ensures that aircraft wings can withstand turbulence and varying aerodynamic loads without failure. Safety factors in design go hand in hand with stress and strain. Engineers never design structures to work exactly at their breaking point. They build in margins of safety to account for uncertainties, material defects, unexpected loads, and environmental conditions. These safety factors are guided by rigorous calculations rooted in physics. Stress and strain also help engineers understand failure modes. Whether it is fatigue, failure from repeated loads, buckling under compression, or fracture due to excessive tensile stress, knowing the physics behind deformation and failure allows engineers to design structures that endure. This is why stress analysis is central to engineering disciplines and why modern tools, finite element analysis, computational modeling, and experimental testing focus heavily on it. Ultimately, the study of stress and strain is a study of safety itself. It transforms abstract forces into actionable design principles, allowing engineers to turn ambitious visions into real, reliable structures. It is physics in action, ensuring that the bridges we cross, the machines we build, and the structures we inhabit are not only possible, but safe. This video is part of the series Physics for Engineers, Foundations that Build the Future, an initiative of the Physical Sciences Consultorium. If you found this exploration insightful, make sure to subscribe, explore more content from PSC, and join us as we continue connecting physics with the real-world art of engineering.